TRAPPIST-1. TRAPPIST-1. He sits 40 light-years away orbiting an ultra-cool red dwarf star. The planet is roughly Earth-size and sits directly in the habitable zone. It's tidally locked, meaning one side always faces the star. One hemisphere experiences eternal day, while the other is locked in permanent night. But the twilight zone between them could have stable temperatures. Scientists believe liquid water exists on the surface. The atmosphere might distribute heat from the day side to the night side. TRAPPIST-1e receives similar radiation as Earth does from the Sun. Its density suggests it has a large iron core and rocky composition. The star is stable and long-lived. Red dwarfs burn for trillions of years, giving life far more time to evolve than on Earth. The main risk is stellar flares. Red dwarfs frequently release powerful radiation bursts that could strip away atmospheres. But if TRAPPIST-1e has a strong magnetic field, it would be protected. Kepler 452b orbits a star remarkably similar to our Sun, 1,400 light-years away. The star is only 10% larger and 20% brighter. The planet is about 60% larger than Earth, making it a super-Earth. It orbits in the habitable zone with a 385-day year, almost identical to Earth's. This planet has been in the habitable zone for 6 billion years. That's 1.5 billion years longer than Earth. If life follows similar timelines, it would be far more advanced. The planet likely has a rocky composition with stronger gravity. You'd weigh about twice as much on Kepler 452b. The increased gravity might result in a thicker atmosphere, better at retaining heat and protecting against radiation. The main unknown is whether the planet has water. Its position in the habitable zone for billions of years suggests oceans could have formed and persisted. Plate tectonics might be active, recycling nutrients and maintaining a stable climate. PROXIMA Centauri. PROXIMA Centauri b is the closest exoplanet to Earth, only 4.2 light-years away. It orbits Proxima Centauri, a red dwarf and our nearest stellar neighbor. The planet is slightly larger than Earth and sits in the habitable zone. Its orbit takes just 11 days because it's much closer to its star. But Proxima Centauri is much cooler and dimmer, so the planet receives similar energy. It's likely tidally locked. One side always faces the star. The day side could have oceans while the night side is frozen. The twilight zone between them might be habitable. Recent studies suggest the planet might have an atmosphere. If it does, winds could redistribute heat. The star is extremely active. Proxima Centauri releases massive flares that bombard the planet with radiation. But if a magnetic field exists, it would deflect much of this. The proximity to Earth makes it a prime target for future missions. We might know if life exists there within our lifetimes. Kepler 186f. Kepler orbits a red dwarf star 500 light-years away. It's the first Earth-sized planet discovered in the habitable zone of another star. The planet is about 10% larger than Earth. Its orbit takes 130 days. The star is much cooler than the Sun, emitting most energy in infrared. Plants, if they exist, might photosynthesize infrared light. They could be black instead of green. The planet sits at the outer edge of the habitable zone. This means it's cooler than Earth, but a thick atmosphere with greenhouse gases could trap heat, keeping the surface warm enough for liquid water. The star is about 4 billion years old, similar to the Sun. That's enough time for complex life to evolve. Kepler 186 appears relatively stable compared to other red dwarfs. If the planet has a magnetic field and thick atmosphere, it could support life. LHS. LHS is a super-Earth orbiting a red dwarf 40 light-years away. The planet is about 1.7 times Earth's size and 6 times more massive. That means significantly stronger gravity. You'd weigh about 3 times as much. The increased mass suggests the planet is rocky with a large iron core. It orbits in the middle of the habitable zone with a 25-day year. LHS 1140b likely has a thick atmosphere. The strong gravity would hold onto gases more effectively than Earth. Recent observations suggest the planet might be covered by a global ocean. If true, it would be a water world with depths far greater than Earth's oceans. Life, if it exists, might be entirely aquatic. The star is older than the Sun and quieter than most red dwarfs, with fewer flares. This makes LHS 1140b one of the best candidates for life. Future telescopes might detect biosignatures in its atmosphere. Kepler 442b orbits an orange dwarf star, 1,200 light-years away. The planet is about 30% larger than Earth with a 112-day orbit. The star is cooler and smaller than the Sun, but more stable and longer-lived. Orange dwarfs are considered ideal for life. They're bright enough to support photosynthesis, but stable enough to avoid destructive flares. Kepler 442b receives about 70% of the light Earth gets. This makes it slightly cooler, but a thicker atmosphere could compensate. maintaining liquid water on the surface. The planet's size suggests it's rocky with possibly active plate tectonics. Scientists estimate Kepler 442b has a 97% chance of being in the habitable zone. That's higher than any other known exoplanet. The combination of a stable star, optimal size, and perfect positioning makes it one of the most likely places to find life. Kepler 62f. Kepler 62f orbits a star slightly cooler than the Sun, 1,200 light-years away. The planet is about 40% larger than Earth. It sits at the outer edge of the habitable zone with a 267-day orbit. The planet receives less sunlight than Earth, similar to Mars, but a thick atmosphere with carbon dioxide could create a greenhouse effect, warming the surface. Scientists believe Kepler 62f might be entirely covered by ocean, a global water world with no continents. The oceans could be hundreds of kilometers deep. The star is about 7 billion years old, much older than the Sun. That gives life an extra 2.5 billion years to evolve. If life started on Kepler 62f at the same time it did on Earth, it would be far more advanced by now. The main unknown is whether the planet has the right atmospheric composition. GLIESE 667 orbits a red dwarf in a triple star system 24 light-years away. The planet is a super-Earth, about 3.7 times Earth's mass. It completes one orbit in just 28 days. Being in a triple-star system makes this planet unique. At different times of year, you'd see up to 3 suns in the sky. The planet receives about 90% of the light Earth gets, but the light is redder. Plants would need to adapt to absorb infrared radiation. The sky might appear perpetually red or orange. The planet's higher mass means stronger gravity, about twice Earth's. You'd weigh twice as much. The atmosphere would be denser. Scientists believe GLIESE 667cc could have liquid water. The star is old and stable. The main concern is tidal locking. If one side always faces the star, only the twilight zone might be habitable, but atmospheric circulation could distribute heat. TRAPPIST-1. TRAPPIST-1g is another planet in the TRAPPIST-1 system, 40 light-years away. It sits just outside the traditional habitable zone but could still harbor life. The planet is slightly larger than Earth and orbits in 12 days. It receives less light than Earth, similar to Mars, but internal heating from tidal forces could warm the planet. As it orbits, gravitational interactions with other planets flex and squeeze it. This generates heat through friction. TRAPPIST-1g might have a subsurface ocean beneath a thick ice shell. The ice would protect the ocean from radiation. Life could exist in the dark waters below. The main challenge is the lack of direct sunlight. Any surface life would need alternative energy sources, but subsurface oceans could be teeming with organisms. Kepler 1229b orbits a red dwarf star 769 light-years away. The planet is about 1.4 times Earth's size and sits comfortably in the habitable zone. One orbit takes 87 days. The star is much smaller and cooler than the Sun, so the planet orbits closer to receive adequate warmth. The planet likely has a rocky surface with possible oceans. Its size suggests gravity about 1.7 times Earth's. Everything would feel heavier, but the stronger gravity helps retain atmosphere. The star is quiet compared to other red dwarfs. Fewer flares mean less radiation bombardment. This increases the chances of a stable atmosphere and long-term habitability.